Bismillahirrahmanirrahim. Assalamu alaikum. My dear student, welcome to our channel Chemistry Unlocked. I am Firoz sir. Today we will start the series of the lecture for the student reading O levels and SSC chemistry. So, my dear student, today we will start a new chapter known as chemical bonding for the student SSC or O level chemistry. So now let's start about our class. Firstly, what is chemical bonding? Definition. The force of attraction, the force of attraction by which atoms are bonded together in a molecule is called chemical bonding or chemical bond. Chemical bonds are different types, that is ionic bond, covalent bond, metallic bond. And another bond is present, that is coordinate bond, that is actually not present in the syllabus of your SSC chemistry. So if you want, we can discuss about this bond also, that is coordinate bond. Coordinate bond. Okay. So today we will start from ionic bond and gradually we will discuss the next types. Firstly, ionic bond. Ionic bond. Ionic bond is occurred between metals and what? Non-metals. So we have to know a very short list which are very much common as metals and non-metals. For example, lithium, sodium, potassium, calcium, magnesium, iron, nickel, zinc, lead, silver, etc. These are the very common metals. Now the non-metals: hydrogen, carbon, nitrogen, phosphorus, oxygen, sulfur, chlorine, bromine, iodine, etc. So these are the very common metals and non-metals list. Here students, look at here. So we will try to make the ionic bond between these metals and non-metals. Okay. So now start bonding. For example, lithium fluoride. Lithium fluoride, you know, lithium is 3, that is 1:2, 2:1. Fluorine is 1:2, 2:2, 2p5. My dear student, when you see the electronic configuration of the metals, then this is the valency shell and this is the what? Valency shell. So, lithium can easily donate this 1 electron, and this fluorine has total 7 number of electrons in the valency shell. So, fluorine has the tendency to receive 1 electron from the others. 1, why? Because it has 2p5. The maximum electron holding capacity of p subshell is 6, you know it. So, to fulfill this p subshell into 2p6, this 2p5 will receive 1 electron. So, this lithium will easily donate this 1 electron from the valency shell. And you also know that the number of electrons that is donated or received or shared by an element will be known as its valency. In case of metal, the number of electrons that is donated is known as valency of that metallic atom. In case of non-metals, the number of electrons that is received by a non-metallic atom will be its valency, or the number of electrons that is shared by the non-metallic atom will be its valency. So, number of electron donation will be the valency for metals, number of electron receiving will be the valency of non-metals, or number of electron sharing will be the valency of the non-metals. Okay. So, try to understand through the example. Lithium 1:2, 2:1. So, lithium will donate this single electron that is present in the valency shell. 1 electron will be donated. So, lithium becomes Li plus. Atomic number will remain same. Remember that proton number or positive charge is not donated during the chemical reaction. It is never be changed. It is only changed when nuclear reaction is occurred. That's why lithium atomic number is not changed here, because it is donating its outermost shell electron, not any positive charge from the center or nucleus. That's why atomic number remains same, but the electron number will be changed like this. Now, fluorine 1:2, 2:2, 2p5. So, 1 electron will be received by the fluorine. So, it will be like this, F minus 9, but here the electron number will be 10. And you know that this ionic electronic configuration may obtain the electronic configuration similar to the inert gases, near inert gases, to get their stability. For example, here lithium ion obtains the electronic configuration of the nearest inert gas, helium, and here it obtains the electronic configuration of neon. So, this lithium ion and this fluorine ion both are stable in nature due to their inert gases electronic configuration. Now, lithium plus fluorine, electron will be cancelled to each other, and Li plus F minus will make lithium fluoride. So, dear student, this lithium is metal and this fluorine is non-metal, and metal will donate electron, non-metals will receive electron, and the metal after donating electron it becomes positive ion or cation. So, this is positive ion or cation, and this is negative ion or anion. This positive ion and negative ion will attract to each other by a electrostatic force. These ions will attract to each other by a electrostatic force. and that is called what? Ionic bond. Okay, so this is a diagram using the electronic configuration. Now we will use the orbit diagram. Okay. Look at here, my dear student. Lithium. This Li for the nucleus of lithium, first orbit 2 electrons, second orbit a single electron. Now fluorine, first orbit 2 electron, and the second orbit is what? 7 number of electrons. Now 1 electron from lithium will be shifted to the what? Fluorine atom. Now what will be happen? After donating 1 electron by lithium, it will be Li first orbit, so Li plus. After donating 1 electron, lithium atom becomes Li plus. Now fluorine first orbit, second orbit. Second orbit will contain 8 number of electrons, and here it is minus and it is what? Plus. So these two opposite ions will attract to each other to make ionic compound, and there is the attraction between these two ions, that is what? Electrostatical force known as what? Ionic bond. So my dear student, metals and non-metals will make these types of ionic compound. Here two types of diagram we have drawn. One is diagram with electronic configuration, and another diagram is with what? Orbit diagram. Now for the next example. Magnesium chloride. Magnesium chloride. Magnesium is 12. 1s2, 2s2, 2p6, 3s2. If 2 electrons are donated, then it becomes Mg2 plus, 1s2, 2s2, and then 2p6. So it will be the electronic configuration of what? Neo. Chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. My dear student, look at here. Here number of electrons in the p subshell is 5. So to get stability, it requires 1 electron. So it becomes Cl minus. So it will be 1s2, 2s2, 2p6, 3s2, 3p6. And here it will be similar electronic configuration of the inert gas argon. Now look at here. 2 electrons are donated by 1 magnesium, and 1 chlorine has maximum capacity to receive 1 electron, because this P5 will be shifted to the what? To 3p6. 3p5 will be shifted to the what? 3p6. So 1 chlorine can receive 1 electron. But electron transition, that means electron donation number and electron receiving number between the metals and non-metals must be equal. So we have to multiply the atom number in a ionic compound by suitable values to make balance of electron donation and electron receiving. So here electron donation is 2 but receiving is 1. So we have to multiply this chlorine 2, 2 and 2. When you multiply, then full equation of that metals, all non-metals will be multiplied. So here magnesium plus 2 chlorine atom will produce 1 magnesium cation 2Cl minus anion, and they will make what? Magnesium chloride. Now, their orbit diagram. Magnesium, just look at here. Using this diagram or electronic configuration, you can easily use or easily draw the diagram of the atom known as orbit diagram. First, 2 electrons here in magnesium. The second orbit is what? 8. In the third orbit, it is what? 2. In case of chlorine, first orbit 2, second orbit 8, and what? Third orbit. First orbit, second orbit, and the third orbit is what? 7. 6 and then 7. So now these 2 electrons from magnesium will be shifted in this chlorine atom. Now try to understand. Here magnesium is 1, here is 1, here chlorine number is 2, so we have to provide here 2. Now after electron donation, what will be happen? Magnesium, first orbit, second orbit. After donation these 2 electrons, here 2 and then 8. Now it will be Mg2 plus. Now your anion 2Cl minus will be produced. So here 2, this is chlorine, first orbit, second orbit, and then finally third orbit. This is Cl minus. So this is magnesium cation and these are chloride anions. My dear students, this will be the diagram of magnesium chloride. So this is your magnesium chloride formation. Magnesium will donate 2 electrons, and that 2 electrons will be received by the 2 number of chlorine atoms, and here 1 cation and 2 anions will be formed, and they will attract to each other by an electrostatic force that is known as what? Ionic bond, and finally we will get the ionic compound magnesium chloride. Similarly, we can draw here the similar types of element of group 2 elements like calcium. Just here calcium. So if we write here calcium, calcium atomic number is 20. So here the electronic configuration will be like this: 1:2, 2:2, 2p6, 3:2, 3p6, and what? 4:2. Look at here, my dear student. Here the orbit number of calcium is 4. So these 2 electrons from the valency shell will be donated. In case of metals, all the time the number of electrons present in the valency shell will be donated by the metals during ionic bond formation. So during the ionic bond formation, metals will donate its 2 number of electrons or the number of electrons present in the valency shell. So calcium will donate these 2 electrons, and it will be what? Ca2 plus. Atomic number will be 20, but number of electrons will be 18. 1:2, 2:2, 2p6, 3:2, 3p6, 18, and it will be the similar electronic configuration of the inert gas argon. So calcium will donate 2 electrons, and that 2 electrons will be received by the 2 number of chlorine atoms, and if we add these atoms Ca here, 2 chlorine, and we will get Ca2 plus and 2Cl minus, that will make CaCl2. Finally, here Ca, first orbit, second orbit, like this. This is third orbit. 1, 2, 3, 4, and this is the last orbit. This is the last orbit having 2 electrons, that is 4th orbit, and that is donated to the 2 number of chlorine atoms, and we will get here calcium cation, and here the last orbit, 3rd, 2, 4, 6, and then what, 8. So dear students, this is the simple diagram of your calcium chloride. So here we can make calcium chloride, magnesium fluoride, just in this way. Okay. Now another example. Magnesium oxide, MgO, magnesium oxide. Magnesium, 12. Here the both valency of both atom, magnesium and oxygen, having the valency 2, but in our previous 2 compounds, calcium valency was 2, but chlorine was 1, magnesium was 2, chlorine was 1, but here both of the elements having the valency 2. 1 is 2, 2 is 2, 2p6, 3 is 2. So magnesium will donate these 2 electrons and it becomes Mg2 plus, like this. Okay. Now oxygen, 1 is 2, 2 is 2, 2p4. So to obtain 6 in the p section of oxygen atom, it requires 2 electrons that will come from the magnesium atom, and it will be converted into oxide like this. 1 is 2, 2 is 2, and 2p6. So it will be similar to the electronic configuration of neon, and here it will be also similar to the word neon. Now magnesium plus oxygen will make magnesium cation and oxide anion, and we will get the compound magnesium oxide. Now for the orbit diagram, first orbit, second orbit, and this third orbit. Now oxygen, first orbit. Now these 2 electrons will be donated to this oxygen, and it will be converted into Mg2 plus, first orbit, second orbit, Mg2 plus. This is what oxygen, first orbit, like this, oxide. This is your magnesium oxide diagram. Similarly, you can draw calcium oxide similar to the what? Magnesium oxide. Okay. Now we will draw sodium oxide. Sodium oxide and aluminum oxide. Then we start covalent bond. Sodium oxide. Sodium is 11, 1 is 2, 2 is 2, 2p6, 3 is 1. So 1 electron will be donated here, it will be Na plus, 1 is 2, 2 is 2, 2p6, similar to the electronic configuration of neon. Oxygen, 1 is 2, 2 is 2, 2p4. Look at here, my dear student. Oxygen atom requires more 2 electrons to make the 2p4 into 2p6. So addition of 2 electrons, it becomes oxide like this. 1 is 2, 2 is 2, and 2p6, similar to the electronic configuration of neon. But here donation is 1, but receiving is 2. It's totally impossible. So we must balance the electron donation number and electron receiving number. So we have to multiply this sodium by 2, and here 2, and here also 2. So 2 sodium atom, 1 oxygen atom will make 2 Na plus 1 oxide and becomes Na2O. Sodium, first orbit, second orbit, and then third orbit. 2 sodium atom, similar to this, and then 1 oxygen atom, first, second orbit, first orbit and second orbit. Now 1 electron in the valency shell, from the 2 sodium, 2 electron will come here, and it will be 2 Na plus, first orbit, second orbit, and it will be this cation and oxide 2, and here 8. It will be the anion. Okay. So these are the diagram of your sodium oxide. Now the last diagram from the side ionic compound example, that is aluminium oxide. A lot of examples are present for ionic compound, but we have given here some examples which are very much common. Then aluminium oxide, L2O3. Aluminium is 13, 1:2, 2:2, 2p6, 3:2, 3p1. So here the number of electrons is what? 3. So that will be donated. It becomes L3 plus 13, 1:2, 2:2, and then 2p6. Now oxygen, 1:2, 2:2, 2p4. Look at the board, my dear student. Here 3 electrons will be donated at a time by 1 aluminum atom, and it will be converted into L3 plus. In case of oxygen, to make it stable, 2p4 requires more 2 electrons to become 2p6. So 2 electrons will make it oxide, 1:2, 2:2, and 2p6, similar to the electronic configuration neon. Now we have to balance the electron number. Here electron donation is 3, receiving is 2. So to make similar the electron donation number and receiving number, we have to multiply here by 2. So here if we multiply by 2, it will be 6, and here also 2. So here we have to multiply by 3, then here multiplied by 3, then here 3. Now my dear students, so 2 aluminium plus 3 oxygen, electron number 6, and they will be cancelled to each other, and 2 aluminium 3 plus 3 oxide will make the compound L2O3. Now try to understand the diagram, that is orbit diagram, first orbit, second orbit, and then what, third orbit. So 2 aluminium, 3 oxygen is required. So here 2, and here oxygen is 3, first orbit, second orbit. Here number of oxygen is 3. So 1 aluminium will donate these 3 electrons. So 2 aluminium will donate 6 electrons. 1 oxygen will receive 2 electrons, but 3 will receive total 6 number of electrons. So the diagram will be L3 plus, first orbit, second orbit, and here it is 3 plus 2 number of aluminum ion and 3 number of oxide ion, first orbit, second orbit. This is what oxide ion. So dear students, this is the diagram of aluminum oxide, that is ionic bond. Now we will start covalent bond. Covalent bond. Covalent bond. So the definition is the chemical bond which is formed by sharing the unpaired electrons of the two non-metallic atoms of the same element or different element is called covalent bond. So here electron sharing is important fact. Electron will be shared by the non-metallic atoms. Now the question is that what electrons or which electrons will be shared? Of course the valence electrons will be shared, but what electrons or which electrons? That is the unpaired electrons. Again, the unpaired electrons present in the valence shell in a non-metallic atom will be paired or bonded. Now look at example. For example, a single covalent bond. Different types of covalent bond, that is single covalent bond. H2 molecule. So hydrogen is 1s1. So one hydrogen has one unpaired, another hydrogen atom has another unpaired, and thus two unpaired becomes paired. That is what single covalent bond or covalent bond between the two hydrogen atoms, and that is what H2 molecule. And this diagram is known as what? Dot diagram. Dot diagram, because here dot sign is used to indicate the electron. Now it can be drawn in the orbit diagram also. So hydrogen nucleus having one unpaired and another hydrogen having another unpaired, and they become paired in this way. So this is another single covalent bond. So dear student, this is H2 molecule, and this is single covalent bond, and here the valence of hydrogen is 1 because its unpaired electron number is 1. In case of non-metals, the number of unpaired electron will indicate the valency. Okay, let's go for another example. Double covalent bond. Double covalent bond. For example, O2 molecule. So 1s2, 2s2, 2p4. So 1s2, 2s2, 2px, 2py, 2pz. You know it from the orbitals, number of p subshell, that is px, py and pz. Every p subshell has these 3 p orbitals. So p subshell has 3p, px, py and pz. Now these 4 electrons will be distributed among these 3 orbitals. So 1, 2, 3, and again 1. So it will get 2 and it will get 1 and it will get what? 1. So in the valency shell, total electron is valency electron. Valency electron. Valency electrons is here 2, 4, 5, 6. Again 2, 4, 5, 6. The total electron number is the valency electron which are present in the valency shell. Valency shell means what? Last orbit or last shell. So this is what valency shell. And these total electrons present in the valency shell will be known as what? Valency electron. But the number of unpaired electron, unpaired means the single electron are not paired. These unpaired electrons will be the valency, so its valency will be what? 2. Now, if we draw the diagram, oxygen having unpaired electrons here, dot sign, that is cross sign, 1 oxygen, and rest of the electrons are 2 pairs like this. They are not bonded, they will not participate in the bonded. So these are the lone pairs, but these are the what? Unpaired. And lone pair and bond pairs are what? Located here. Another oxygen atom, 2 unpaired. 2 unpaired. So 1 unpaired from this oxygen, another unpaired from this oxygen will be paired, and this is a single covalent, and this is another single covalent. Total is double covalent bond. Now this oxygen atom has 2 pairs electron as lone pair. So these 2s2 electrons and 2px2 electrons will be present in the valency shell, and that must be drawn in the structure or diagram because we are making the bond with valency shell or outermost shell. So we must draw all the electrons that are present in the outermost shell. So in the outermost shell there are 2 unpaired and there are 2 lone pairs. 2 unpaired is this that will participate with covalent bond forming with another 2 unpaired of another oxygen atom. So this oxygen atom has 2 unpaired, and here is 2 unpaired. This unpaired will be paired, and here unpaired will be paired. So we'll get these types of diagram. Double covalent bond. Double covalent bond. This is the diagram of O2 molecule, that is dot diagram. So this is what? Dot diagram. Now orbit diagram. Similarly, oxygen atom, and we have to draw the just valency shell here. So oxygen atom has total 6 electrons like this, and this is unpaired, this is another unpaired, 2 unpaired of 1 oxygen. Similarly, that will be paired with another oxygen atom having 2 unpaired like this. So here that will be paired, and here that will be paired, and here 2 electrons, 2 lone pair, 2 pairs electrons as lone pair like this. So this is oxygen nucleus, this is oxygen nucleus, this is a covalent, this is another covalent, that is total double covalent bond, and there are 2 pairs electrons in a single oxygen atom as lone pair. So these are known as what? Lone pair electrons. And what are lone pair? Non-bonded pair. Lone pair electrons. That means non-bonded. Non-bonded paired electrons is called what? Lone pair electrons. And these are the bonded. These are the what? Bonded pair of electrons, or here double covalent bond. So these electrons are called what? Bond pair electrons. Bond pair electrons. So the electron pair which participate in the covalent bond is the what? Bond pair, and not participate in the covalent bond is called what? Lone pair electron or free pair of electrons. So in O2 molecule, you can observe that here 1 pair and here 1 pair, there is total lone pair here 2, and here also 2. The total in O2 molecule is 4 lone pairs. So total lone pair in O2 will be what? 1, 2, 3, 4 pairs. And total BP, that means bond pair, 1 and 2 pairs. Total bond pair will be 2 pairs. So this is the explanation of your double covalent bond. Now we'll move to the triple covalent bond. Triple covalent bond. Triple covalent bond. Triple covalent bond. For example, nitrogen 1s2, 2s2, 2p3. 1s2, 2s2, 2px, 2py, 2pz, 1, 1 and 1. So this is the valency shell. Valency electron is here 2, 3, 4, 5. Valency is 3. Why? Total number of electrons is valency electron, but the number of unpaired is valency. Now, nitrogen 1, 2 and 3. 3 unpaired one nitrogen has, and 1 pair as lone pair. Another nitrogen atom has 1, 2 and 3 and 1 lone pair. So they will make this triple covalent bond like this, and that is the one N2 molecule. Now orbit diagram. First orbit, and then what? Second orbit. 1, 2, 3. Another nitrogen atom has 1, 2, 3. Okay. So nitrogen, only valency shell is enough. So this is nitrogen. This is the single covalent. This is another single. This is another single. That means total is what? Triple covalent bond. So nitrogen atom will show triple covalent bond, and here one lone pair and here another lone pair. So this is the diagram for what? Nitrogen molecule. Okay. So here total lone pair, LP means lone pair. Total lone pair equal to 2 pairs, and total BP equal to what? 1, 2 and what? 3 pairs. Okay, my dear students. So this is the another diagram of covalent molecule. So in this lecture we have already discussed just ionic bond and many example of ionic bond or ionic compound, and started with 3 examples of covalent bond, but we will discuss a huge number of or more number of molecules of covalent. So in this video we will finish after this, but after this lecture, in the second lecture of chemical bonding, we will discuss more about the covalent compounds and different properties. So wait for the next classes, and until then, Allah Hafiz, Assalamu alaikum.